Okay, the next problem on the agenda is problem 10H, which is to determine the maximal domain and the corresponding range for this function here. F of x is 1 plus tan squared x. So let's start off with the maximal domain. Well, this function here is defined for all values of x, apart from when x is an odd multiple of pi over 2, because that we know that the tangent function expands. So we can write down the maximal domain is, well, what is it? So let's get an equation, copy this down here. Well, it's x is in the real numbers, so we'll write that as, what will we write it as? Well, we'll write that as x is in the real numbers, but there's a proviso, and that is that x is not equal to, so we'll put another bracket around here, not equal to n plus a half over 2 times pi, pi colon n is in the set of integers. So there we go. So that's the solution to that problem. Well, the next problem is question 12, and that's about the combination of functions. So we've got two functions here. F of x is equal to x minus 1, and g of x is equal to 1 over the square root of x minus 1. So we're asked to give explicit forms for f plus g of x, and that's just equal to the sum of those two functions. So in other words, that's equal to and so that's the first part. This notation here says that we want the product of those two functions, so let's copy this bit down here. And instead of adding them, we need to multiply them. Now, g of x is only defined for x greater than 1. So if x is greater than 1, x minus 1 is equal to the square root of x minus 1 squared. So in other words, this is equal to and then we take that and then we square it like so, and then we can see that that is actually, that this cancels with one of those if x is greater than 1, and so the answer is just that. f over g of x is got by dividing f of x by g of x. So let's copy that down here. I don't want that. And now we divide those two. And of course the result of that will be moving that up to the top, so that will be equal to this guy here raised to the power 3 over 2. And oops, we made a 2. And now the last one is f circle g of x. Now that's the composition of the two functions. In other words, that's f of g of x. So let's write that down. X. And so what we do is we take f of x and wherever we see x, we replace that by g of x. And now we put in whatever g of x is, so that's equal to Control C. And we copy that. Too many equals. And now we copy g of x. And that's the answer. And all these functions, of course, are only defined provided x is greater than 1. So that's the solution to that problem. Okay, so the next problem is problem 13e, and we're asked to draw a neat sketch, preferably without using calculus, of the graphs of the following functions. Let's find out some facts about this function. Let's call it f of x. Okay. So what do we know about this function? Well, firstly, we know that f of x let's put an equation down there. So we copy this equation. The first thing we know is that f of x, if we look at it, is positive, because for any value of x, x squared is positive, and we add 4 and it's still positive, so it's greater than 0. The next thing we notice is that for any positive or any value of x, x squared is positive, so the numerator is always greater than 4. So in other words, the function is always less than or equal to, it's when x is 0, 1 over 4. The next thing we notice is that f of x is an even function, so i.e. f of x equals f of negative x. And finally, f of x tends to 0 as x tends to plus or minus infinity. Let's get that out. Plus or minus infinity. So in other words, it's the whole curve lies between 0 and a quarter, and it has a maximum value of a quarter when x equals 0. So let's draw a graph of it. We can't really draw neat graphs, so we'll take our plotting tool, customize it a bit. So we just want to plot this function. And here it is. And as this, it looks like what we expect, or not quite, so we need to want to see it between 0 and a half, and there it goes. And you can see that's roughly what we expect. It has its maximum value at a quarter here. It's the bit on the left is the mirror image of the bit on the right, and it comes slowly down to 0 as x becomes large.